Hello everyone, welcome back. I'm back with another video. Today we're going through the third step of the statistical journey of each research, the data cleaning and exploratory data analysis part. In the previous episode, we talked about the first two steps, understanding the research question and identifying variables correctly. If you haven't watched that video yet, I highly suggest watching it first, even if you're good at variables types, because we introduced 3 real projects there that are the core data sets for this series, and we will refer to them the entire series. You're going to need to know them perfectly so you won't get lost for the rest of the episodes. And here's the link to the video up here in the right corner. So let's get started with getting to know the data sets first. For the psychology project, we're exploring the effect of imposter syndrome on the research confidence and academic performance within 150 students. Variables are students' ID, age, gender, year of study, study hours, imposter syndrome, which is continuous, as do research confidence and GPA. The health study investigates factors related to hypertension among 300 patients with variables of patients' IDs, age, sex, BMI, body mass index, smoking status, physical activity, which is a categorical variable with 3 levels of low, moderate, and high, cholesterol level, and finally hypertension. Hypertension's values are the status of having it or not, which is indicated by 0 or 1. 0 not having it, 1 having it. And the last project, an environmental study, which examines air pollution and environmental conditions. We have 365 observations dedicated to each day of the year that these variables were measured. So variables are date, station, at where variables were measured, temperature, humidity, wind speed, rainfall, traffic volume, and finally the measurement of air pollution, which is indicated by PM 2.5. So now that we know the variables, we need to know the numbers, the nature of them, what actually is in there, and what's the situation. To do that, we use str function, and it will give us a snapshot of the situation. So run it. And here's the result in the console window. As we already knew, 150 observations, students, 8 variables, and their types. Int means variable is integer, chr means its character type, and num means they are numeric. So let's go further and get some descriptive stats. To do that, use summary function, run it, and you see here minimum, maximum, median, mean, first and third quartiles for each variable. The next step is checking missing values. This line here says sum each column's number of null or missing values, right? So run it, and there we have 5 missing values for study hours and 4 for research confidence. As you can see, it's a small number. So for now, we just keep them in mind and we move on to the next step. In the next step, we want to understand the shape of the data itself. We want to know if they are symmetric or they are heavily skewed. This matters, but why? Because many statistical methods make assumptions about the data distribution, and if they are not symmetric, for example, let's say if they are not normal, we cannot use the test that needed normality assumption to be met. So it's a very important step. Here we are most interested in the skewness that shows us the distribution of the data. You see a skew for imposter syndrome is negative 0.23 and negative 0.02 for research confidence and negative 0.22 for GPA. As you can see, they are all negative and close to 0. That's encouraging because it suggests that these variables are fairly symmetric and do not show severe skewness. However, it does not guarantee that other assumptions are satisfied. But don't worry, we'll get there in the next episode when we are going to be checking the entire assumptions. Another important thing that we should always check is outliers. To do that, we need box plots to show us the points that are way out of the acceptable range of each data set. So again, these three variables are most important ones. And to get the plots, you only need to write boxplot function and indicate the variables that you want to get the plot for them. So run it. And you see the results here in plot window. See, only the first one, the one for imposter syndrome, shows two observed outliers. It says that two students have very low imposter syndrome scores compared to the rest of the sample. So I want you to pay close attention to this part. The important question is not asking, should we delete them? Should we delete these outliers? No. The important question is, are these values mistakes or are they just real students who genuinely experience very little imposter syndrome? So since these values fall within the possible range of the scale and do not appear to be data entry errors, we can confidently say we would typically keep them. Before moving on, I want to have your attention again on variable types. As you may remember, here the gender variable was character and categorical. So in order for our studio to treat it properly and count it in the analysis, we need to convert it into a factor before doing any test. And we do it using as.factor command. So run it and here you go. For now, we're done with the psychology dataset. Let's do the same for the two other ones. And then we will come back with EDA or exploratory data analysis part 2 in the next episode. So again, we run str function and you see 300 observations, 8 variables. These are integers. And then I have converted sex into factor before, smoking status, and so on. Nothing is strange or unfamiliar to us here. Then in the next step, get the summary again. And here it is. Notice the number of smokers here is almost half of non-smokers. And since hypertension is a binary variable, the result is not helping us here. So we don't need that. You can just ignore it. Then we need the scribe to get the skewness for BMI, age, and cholesterol. And you see they are relatively small. BMI and cholesterol appear reasonably balanced. And for smoking, it is normal because it's hard to find a lot of smokers. So at this stage, nothing immediately suggests a major distributional problem. And we're good to go. Next, let's see if there is any missing data. So run it. And as you can see, we only have 6 missing info for cholesterol level and 8 for BMI out of 300 patients. When we only have a handful of missing data, we have more flexibility on how to deal with them, how to handle them. For now, we just keep them. Then let's see outliers. So as you can see, we have 4 or 5 outliers for BMI here and here, and just 1 for cholesterol level. At this stage, I would say, let's go deeper and see the exact numbers of outliers. So to do that, use boxplot.stats, which will give us the exact numbers. This line literally says, give me the stats related to boxplot for age variable from health dataset. So run it. BMI outliers, 43, 13.6, 43.3, and 13.2. A BMI of 43 is unusually high, but it is medically possible. And as for BMI of 13, it is extremely low, but again, it is still possible. Therefore, we can conclude that these values are unusual observations, but they're not necessarily mistakes. So we'll just can keep them. And for cholesterol, again, 300 is high, but it's realistic. You can find people with this high level of cholesterol. So we can keep it, and age has no outliers. Okay, we're good to go to the next data set, the environmental project. Run str function again, and you see 365 observations, 8 variables, and these are numeric. Don't change them. They should be numeric. But for station, they have characters of E, D, B, station of E, station of D, and station of B. But I think we need to convert them to factors so they can be included in the analysis. Then let's get the summary too. Next, let's see the shape of the distributions now. Run it. And you see, except for rainfall, they are all near zero and well balanced. So we're good here. For the number 1.6, it shows that some days had less rain compared to others. That's very usual and reasonable environmental phenomenon because it's not supposed to rain every day or half of the year, right? Unless you're located in somewhere like England. Anyway, then count the number of missing data, run it, and you see we have 7 missing observations for humidity. Here, at this stage, given the size of the dataset, this is unlikely to substantially affect our analysis, so we can just leave it as it is for now. Now, let's see if there is any outliers. So again, draw the box plots. These 3 variables are the most important ones and directly related to the research question, so we only have the box plots for them. Run it. And see, we have outliers for all 3 of them. We'll get the numbers to decide whether we want to keep them or not. So again, use this line. So 64.4 for PM 2.5. It is very realistic. It shows a high pollution day. But these numbers here, 5,000 something. For traffic volume, they are very high. But I would say they are still realistic because maybe it was a holiday event, maybe it was a festival, or maybe it wasn't just unusual traffic due to an accident or something else. So as long as they are all within the realistic range for traffic, we can keep them. And here they are. And 18 for humidity. You may say it's low. It's correct, but it's not impossible. So we'll keep this one too. And that was it. Today, across our 3 projects, we found several outliers. None of them appear to be impossible values. Therefore, removing them would mean removing genuine information. Now, as good researchers, we know that we are not allowed to remove observations simply because they are unusual. We first evaluate them, then we decide what to do with them. So, dear friends, I think for this episode it's enough. We'll get back with the ADA Exploratory Data Analysis Part 2 section, and hopefully after that we will see what test best suits our datasets. As always, thanks for watching. If you have any questions, drop it in the comments, and please like and subscribe to my channel so I can get motivated to create more videos. I'll see you in the next one.